So you can finish whatever you need to from those 3 pages, 29, 30, and 31. Is there anything from yesterday that we talked about, 26, 27, 28, that I went over? Had I put the solutions up, or is there anything from there that you'd like to see? Just let me know. As promised, I made copies of the trig cheat sheet, that 4-page, those 2 pages front and back. Does anybody want a hard copy of that? Just for your reference, just to make things easier if you have not printed it out yet. It's nice to, now that we're back, to be able to just peek at it whenever you need to look at the circle or look at identities, because the second half of chapter 1 we start to look at some limits of trigs. So that's there for you. The other thing that I want to give you now, so you can get started whenever you want, if you want, and this is completely optional, the practice quizzes. Okay, what I did on the PDF of the whole first chapter there, but on today's announcement, I'll let you know which practice questions are okay to skip, because I won't be putting anything like that on the quiz that you'll see get sent out to you, I don't know, like tonight or tomorrow, sometime that you have up until Sunday night to work on. But the style of questions, like I said, is just a little bit different. And so that's, I think, the best part about these. And I will do the solutions. I'll put them up. You don't have to submit them. It's just totally up to you. If you think it's going to be useful for you, spoiler alert, it will. You'll see the style. You get used to those kinds of questions. So why not? But there are a couple that you can skip along the way if that makes your life a little easier, less to worry about. Okay. You already got one. You're welcome. There you go. Okay. So, what I want today to be, if possible, is a chance for you to finish up that 1.4, okay? Because it is due tonight before midnight. You can work on it. I've done all the solutions, so I'm happy to pull those up as you work through it. If you're like, I want to see if I'm doing this right, or I don't know what to do, how can I work through this? Again, if you want to skip 10, 13, 18, and 19, it's 2 piecewise ones, and then 2 with the complex fractions, kind of the messier adding fractions up top. Ones. At least the limits work out for those 2, which is nice. But I did them all. I did every single one. Let's see if I can pull it up now. Yeah, there it is. Okay. So I will leave kind of the beginning few up, so you can check them out. Folks at home, I'm not going to add this to Canvas yet, but if you want to look at a question, just tell me and I will scroll. Okay. But you guys at home, you guys are good. If you want to stick around, great. If not, you can head out and I will literally see you not until Wednesday in person, but Tuesday we'll be back hybrid for you guys, okay, remotely. So stick around if you want and ask questions, finish this up, or I will see you. Put on some music or something. Get some work done. Give me a shout if you need something. Put in your own music. If you don't want to, I'm going to put on some in the background. I'm sitting here in silence. And I'm happy to help, so let's get to it. You guys want to just give me a shout if you need anything. what I'll do is I'll start working on the answers to the quiz. So really the biggest takeaway that I want you to have from these practice quizzes is looking at the styles of the multiple choice questions. That's what's going to be probably unique to your math life. Not that it's unique to you because you've taken things like this before, but if you just look at that front page, which of the following statements are true, right? 1 and 2, or just 3, or 2 and 3, or 1, 2, and 3. And you have to decide kind of individually, looking at those Roman numerals, okay, is this a true statement? Okay, let me look at the graph and figure out if the left side is in fact the same as the right. Like, can as I approach -3 from the right, is that the same as the value of the function? Right? You want to kind of piece those things together. And so what you'll see me do up top as I work through a question like number 1 is I will, like, next to number 1, put a true or a false. Like, I will actually work through that separately, see whether it's true or not. And then I'll do the same thing for Roman numeral 2, and then the same thing for Roman numeral 3, kind of figuring out if those statements are true separately. Then I will select the right A, B, C, D, or E based on that. That makes sense? Same thing for number 2, right? They've got Roman numeral 1, 2, and 3, and that's about the same graph. So I look at that limit. I just figure out if it exists. Then number 2, I look at that limit, see if it exists. Look at number 3, does that limit exist? And then I'll pick the right multiple choice based on that. Okay, that's an AP style multiple choice calculus kind of question. Okay, but feel free to skip. What did I say? All of something. Announcement. Number 3 on page 42. All of page 43. And you're going to see that these are just 2 practice quizzes that are almost identical. Like, even some of the graphs are the same. Some of the questions are exactly the same. Some of the questions are different. So that's why, like, 42 is number 3 and 46 is number 3. It's the same kind of question. Page 43, all of it. Page 47, all of it. They're the same kind of question. So that's why we're switching. Okay. But I'm going to call it quiz 1.1 because we might do a quiz 1.2 for the second half. We'll see how time works out. I would love to get it out to you tonight if I can. Okay, but we'll see. Either way, you have a couple days to do it. It's open notes, but not open friends. Okay, so just do it, just you. It should be pretty straightforward. I just want to see where you're at. I'm going to guess, I haven't made it yet, but I would guess like around 40 points-ish, where a test would be out of 100, so you have kind of a gauge there as to what you want to get to that. But I haven't written it yet, so we'll see what happens. Sure. So I've done what's on your desk. So I'm doing this right now because I've already done the solutions to that. But what's on your desk is what's due tonight. So make that your first priority. Yeah, pages 29, 30, and 31. This is optional. This is just to kind of get you prepared for what the quiz is gonna look like. Yeah. So what I would probably do for number 9 is plug in 0, 0, 0. Now the whole, but once you eliminate this, I should be able to factor. So if we factor out the common factor, top and bottom, we should get to a point where you're pulling out the x squared from the top and the x squared from the bottom. Because then you cancel those out. Because that's the issue, is having that x squared, right? That smallest value of x I can pull out. Because then once I divide that away, now I can just plug in 0. Yeah. On number 5. So number 5 is a little rough because the limit exists because I can just plug it in, no problem, but I have to evaluate tangent of 5 or 6. And I jump on my calculator and I hope and I pray that this is some super nice number, but it's some decimal. And so the issue with that is that if we're going to actually do it right, we have to evaluate it by hand. So tangent is sine over cosine. So what I'm doing is I'm doing sine of pi over 6 and then cosine of pi over 6 and putting them on top of each other. And so I'm like going to my unit circle and I'm saying, okay, what's the y value, sine, and then what's the x value, cosine. Now, what I can do, because I have complex fractions, I have the same denominator, I can at least cross those out. They're both being divided by 2, so simplify. And so I get 1 over radical 3, right? The 1 from the top, the radical 3 from the bottom. Now, you can choose to rationalize, multiply by radical 3 over radical 3 to get to here, so that I can do pi over 6 squared, and then tangent of pi over 6. So there is pi over 6 squared, square the top, square the bottom, and then here's my tangent. Or, if you want, you can leave it as 1 over radical 3. Welcome to calculus, where you no longer have to rationalize denominators to get full credit for a problem. So I could just leave this as pi squared over 36 radical 3. That'd be fine too. But the downside to this problem is tangent of pi over 6 is not 1 or 1/2 or something nice that the calculator gives me. It's whatever that decimal is, 0.7, blah, 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 blah. But I always try. I'm always going to jump, if I can, I'm going to jump in my calculator, I'm going to see if it's nice. If it's not, well, okay, if it was just sine, I just go to the y value. If it was just cosine, I go to the x, at that spot in the circle. But tangent is sine over cosine, so y over x. If it was secant, okay, 1 over cosine. I can always go back to sine cosine, so I can evaluate it directly. So either setup, the one in blue or the one that I wrote out, would be fine, because this is an FRQ, so get yourself to a simplified best answer. If it was multiple choice, only one of those solutions would be there. So that's why you want to kind of be careful recognizing whether or not they rationalized or not, because that will kind of lead me through this. So I just kind of like did a little side work here just to figure out what that was before I jumped back in. Sure. So choices on number 11. You can factor it. See what happens. I really like the expansion instead. I took 2 plus x cubed and I multiplied it all out. Like I did 2 plus x times 2 plus x times 2 plus x. I just made my life a whole lot easier. I know it doesn't maybe look as easy, but it is a lot faster. I was super slow with it. I used Pascal's triangle to expand. The expansion, let me see if I can sneak it under here. The expansion of a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. There's 2 cubed. There's 3 times 2 squared times x. Right? Because a is 2 and b is x in this setup. And then there's 3ab squared, and then x cubed is the b cubed. Just kind of off the side like that. Trying to see it's actually probably easier if I make that go away. Here, let me rewrite it. A plus b cubed. All right, right on top. There's a cubed right there. This is a plus 3a squared b plus 3ab squared plus b cubed. There we go. Now they're stacked on top of each other. Now it's 1, 3, 3, 1 from here. That's all I get from this. The thing that we have to remember, and I wrote it out the long way, so it's super obvious where it all came from. So there's 1, 3, 3, 1. There's the coefficients. Make those go away. It's easy to see. A cubed, so like 3 and 0, like your exponents have to shift. Like 3, 0, 2, 1, 1, 2, 0, 3. Right? And we did this with binomial expansion last time. So took the first term, cubed it. Second term gets nothing. So x is 0, is 1, so it goes away. Then I drop this exponent down 1, and this exponent moves up. It stays balanced. 3, 0, 2 and 1, 1 and 2, 0 and 3. And then I go from there. I just kind of take my time and expand it out. I think that's the easiest way. Because the other thing that you could do, it's nice, it works, it's just not as easy, is to see it like this. That whole numerator is the difference of 2 perfect cubes. The first one being 2 plus x, the second one being 2, right? That is 2 plus x cubed and 2 cubed. And you can factor. And one of those factors would eventually be just x, and they would divide by. Let me do it out so you see it. Color. So it's this. 2 plus x is being cubed, and then I'm going to subtract 2 cubed. So a, same sign, same, minus b. A squared, opposite, plus a times b, always positive, plus b squared. A squared, ab, b squared. And it's nice, it's kind of cool that it works out that way, but it can get a little messy because like a is a binomial. You have to hold on to that the whole way. Because now, simplify the inside, okay, x. And then I'm going to multiply all this out. So 4 plus 4x plus x squared plus 4 plus 2x plus 4. Well, x squared, 6x. And remember, all of this is all over x, so eventually you cross that out. X squared plus 6x. That takes I feel like that takes a lot more thought and careful kind of approach to it. This one is just multiplied out. Watch the numbers cancel out, 8 and negative 8. Factor out the common factor of x to be divided by. That's one of the hardest ones on here, I think. So 13 was an optional one. And the reason that I made it optional is because it was looking at a piecewise function. But if we look at the setup for it, it kind of tells us what we need to be able to do. So look at what x value we're trying to get close to, right? 2. And look at where the break happens in this function, right? So one function stops at 2 and the next one starts. Now, neither of those include 2. Right? It's not x is less than or equal to, or greater than or equal to. So the function is undefined at that spot. There's a hole somewhere, and they're both going towards it, or there's a hole in 2 different places, one heading from one side and one heading from the other. So that's kind of the situation we want to figure out. Are they both headed towards the same hole? And so what I do is I check both one-sided limit, and I will compare the two. So if I want this limit to exist, then both of these have to be the same. Now, how do I do that? Well, if I'm approaching 2 from the left, here's the function to the left of 2, which means I can plug in 2 to that top piece of the function to see what y value I'm getting close to. I'm not actually ever going to get to 2, 0. It's undefined there, but that's the y value that I'm approaching. How do I know that? Because this is defined and continuous everywhere. So I feel really good about just plugging that number in and seeing what I get. And so that's what I did. I plug in 2 to the top one, check it. Now if I want to go from the right, here's where that happens, right? X is greater than 2. Okay, so that's to the right of 2. So I will plug in 2 into that bottom piece, see what I get. Those two limits, 0 and 4, are different. Therefore, that limit is. So with piecewise functions, at the break point, you check one, you check the other, just pick the correct one. So you're saying the right thing from the left and from the right. And you see what you get. And you'll see, I'll skip just to the other ones so you can see it in action. Because it happened again, number 19, I think, yeah. Scoot it down. Where's my buttons? Oh, there they are. Why did you put it right in front of me? It's so weird. I did the same thing. You check the left and right hand limits separately and then compare those. This one was nice because I had a lot more space to write in. So here I am to the left of -2. Here I am to the right of -2. So when I'm to the left, I plug it into the top one. And from the right, I plug it into the bottom one. Those two numbers are different. Therefore, that limit doesn't exist. I won't put a piecewise one on the quiz, but I wanted to do the answers so you can see how they do it. And to save myself some trouble, I just said, okay, here's f of x. I named it f of x, so I could write it just the limit of f of x, or g of x, or h of x, call it whatever you want. Because if you just say the limit as x approaches -2 and you don't say of what, you are incorrect. You're missing the noun in the sentence, right? You know what I mean? That is grammatically incorrect in terms of the mathematics. So I either had to give it a name separately, like I did with that. Hey, I'm going to call this f of x, and I did it explicitly. I said it, I circled it, here it is. Or I would have had to write this piecewise function right here and right here. I can't say the limit is x approaches -2 without telling you of what. And it's just easier for me to give it a name and then call it whatever I want. Cool. How about some multiple choice answers for the first one? In case you want to see how you're doing. Again, feel free to skip 7. I think that's, yeah. And all of page 43. And if you wanted, you could skip 3, but hey, it's good practice. But that's just what I did. If I had, like for part, like Roman numeral 3 on number 3, even part 2, I had to know which pieces to check to be able to do it. But I won't do that. There won't be any piecewise on there. Negative everything. Yep, perfect. Yep. So a lot of stuff should cancel there. So the thing that you want to watch out for, that's a good one to look at too. And like they sneak this one in here, and it's the most important one in calculus. Look at number 12. You recognize that at all without the limit? That, exactly, yeah. Is that the, what's it called? What's it called? Anybody remember? Nice, it's a difference quotient, yeah. That's the difference quotient. We looked at that in pre-calc. Now we're going to take the limit of it. And you're going to see why, beginning of chapter 2. But look, h is the thing that's going to 0, not x. So you're going to end up with x still as part of your final limit there, because we're just going to let h go to 0. But I can't do that yet because I'd be dividing by 0. So I have to figure out a way to hopefully get to a point where I can factor out h and divide it away. And that's what we did in pre-calc. It was like chapter 1. They like snuck it in on us and they said, okay, let's just try this. It was f of x plus h minus f of x. Oh, gross. All over h. That was the difference quotient. And that's what's sitting there. So there's the function x squared plus 2x minus 3. And they said, okay, everywhere there's an x, change it to x plus h, see what you get. And the way that we did that is we always expanded, simplified, factored out h, and divided away. And now, once I do that, now I can let h go to 0. But x is still x. Yeah. You just want to be careful as you do that everything like this subtraction that happens in front of here is going to change the sign of everything inside. So negative x squared minus 2x plus 3. And what we saw last time is that if you end up, after you expand and simplify, with everything having an h in it, you probably did it right. But if something does not, you definitely did it wrong. Okay, the difference quotient will always cancel out everything that doesn't have. Sometimes even some of the h's as well. That's just lucky if it works out that way. But I need at least a common factor of h everywhere so I can divide it away. Don't forget the parentheses around this polynomial if you're going to take the limit still. Yeah, that's how that one looks. That's a good one. That's the basis of all of calculus. That right there. That limit, number 12. And they just like sneak it in for the first time in these problems. Like that's all of chapter 2. And all of our shortcuts that we learn beyond that are because that works the way it does, which is so cool. So I think pages 41 and 45 are identical. Because these are just 2 practice quizzes that they send out. Well, really like, these are some of the quizzes that they think you should take, but I like to practice first. So let's see, they call it like quiz number 1 and then quiz number 1 with a star. So there's going to be some repeats. This one looks identical. Compare other pages too. So this is same. That's not good. Number 3 is the same. 4 is different. 5 is the same. So 3 is the same. So if you're going to do anything on page 46, do number 4. That one's just a little bit different. This one is the same. Oh, I guess 6 is a little different. It's like they just put different functions in different spots. They just swapped D and E, C and D. That was the only difference. So it's really the same because the answer is neither of those. So I mean, it's basically the same question. Let's keep looking. I'll put this all on Canvas so you don't have to know it for sure right now. I said page 47 is optional, so you don't have to worry about that. But 7 is different a little bit, but we haven't talked about stuff like that yet. We don't really have to until we get to chapter 2.
Hey, Rosie.
Oh, what's up?
Can you go over 15 for the homework?
Absolutely.
Thank you.
You're welcome. All right, 15. Okay, so 15 is a really good example of that rationalizing thing that we have to do, right? So I can try to get to the point where I have something to divide away, right? I want to try to divide away that x minus 1 somewhere because I'm trying to go to 1. And I think about whether or not that's even worth it by seeing if there's a hole there. So like in my mind, I plug in 1 and I check it out. I get 0 over 0, so that's good. And the only way to do that is to rationalize by multiplying by the conjugate, top and bottom. Multiply out the square roots, but leave the denominator factored in the hopes that we can divide away the x minus 1. Once we divide away the problem, because it's a removable discontinuity, so we should be able to just remove it, things look good. Does that make sense?
Yeah, thank you.
Cool. Oh, I guess the order for number 1 is different. They put the answers in a different order, but the question is still the same. Oh no, I guess they go from the left and from the right. Whatever, I'll just do it. Stop being lazy, Rosie, and just do the problem. It looks so similar. It's the same graph, slightly different questions. Oh yeah, it is different. Okay. So last minute or two before we are out of here, so get yourself to a decent stopping point. Yeah. Okay, so there's a really nice little trick that Zyba actually helped me out. We're trying to remember how to do this. So factoring quadratics when A is bigger than 1, or just different than 1. Now, factoring by grouping or the 2 by 2 square, like all of that still works. But there is a really nice shortcut that if you just say, okay, what 2 numbers add up to B and multiply to A times C like we always do with quadratics, and you find those numbers, you can still set it up as if it was just x squared. Now we know that that's not right because it's 2x squared, not x squared. So it's just kind of like a step in between. And what we do to get A, whatever it happens to be, whatever A is, we're going to get that involved. And so here's the neat little trick. Take your number and divide by 2. Divide by whatever A is. If it goes in evenly, you get a whole number back, then do it. Like actually divide. But if you don't, like 3/2, right? That does not go in evenly. I simplify the fraction if I have to. Cool, done. And then I take that denominator and it becomes my coefficient. And it's this algorithm that just kind of avoids all of the algebra that is happening in the background. It's still the same thing. It is definitely a foolproof process. And then, so just kind of like leave that off on the side and see where it gets. Yeah, you're welcome. Have a good day, everybody. Check Canvas tonight, tomorrow. I will post your quiz that will be due before Sunday midnight. Thanks, everybody.
Thank you.
You're welcome. See ya.
Thank you.
You're welcome.
Mr. Rosengrad.